Hello, good day. In this virtual class, we shall be looking at some questions on logarithm. Here, say if P and Q are positive numbers, prove that log P to base Q times log Q to base P equals 1. Okay, we see that we can see inverse here. The base here is the log here, while the log here is the base here. Okay, so here typically to resolve these questions, we adopt uh, the change of base. Okay, they say hence or otherwise express y in terms of x if 3 open bracket log y to base x minus or log x to base y close bracket equals 8. Now let's look at the question and see how we can um, look at it and resolve it. Now, this is the question before us. Log P to base Q times log Q to base P equals 1. First of all, let's assume that log P to base Q equals X. Okay. Now, this expression, log P to base Q times log Q to base P become X times log Q to base P, because we've already said that log P to base Q equals X. So from definition, we can see that P is equals to Q raised to the power of X. You know, from logarithm, the definition specifies that the logarithm of any number is the power to which the base must be raised to give that number. Okay, so here is the base. Then for us to get P, it means that we raise the Q to the power of X. So that is the definition. Now, assuming we now take the log of both sides to base P. So this becomes log P to base P is equals to log Q raised by X to base P. We know that log PP is equals to 1. Okay? And log QX, Q raised by X to base P can also be written as X log Q to base P. So here the here becomes 1, this becomes 1 is equal to x log q to base p. Now the essence of doing this is that we're asked to show that this two expression is equal to 1. So we will try to manipulate log p to base q so that here we have the same expression as q log q to base p. So here, for us to obtain x here, we are looking for an expression for x by dividing both sides by log q to base p. This becomes 1 over log q to base p is equal to x log q to base p divided log q to base p. So that x here is equal to 1 over log q to base p. Here we'll make use of what we call the change of base. It's one of the law of logarithm. Very, very essential. Okay. Now, all we need to do, we recall back here that we said that this is equal to this, and x now has an expression of 1 over log q to base p. So that in place of x, we substitute 1 over log q to base p times log q to base p, and this cancel this. Eventually our answer is 1. That means we have tackled the first part of the question. Now the expression, yes, the other part say hence otherwise find y in terms of x if we have 3 log y to base x minus log x to base y equals 8. Okay, so 3 into y to base log y to base s minus log x to base y close bracket is equals to 8. Now, first of all, we will also use the same definition by letting log y to base x is equals to p, so that y is equals to s raised by p. And if we do that, that means we can use change of base here by turning this one to be 1 over log y to base x. So that here in place of since we have said the whole of log y to base x is equal to p. This becomes 3 into p minus 1 over p close bracket is equals to 8. Now, to clear this is a fraction already. For us to obtain, to clear this fraction, we'll multiply through by p. Okay, so here this becomes 3p times p. Here this becomes minus 3 times 1 over p. Okay, times p times p. Okay, is equals to 8 times p. So that the whole expression p cancel p here, 3p times p become p square, and 8 times p equals to 8p. So the whole expression becomes 3p square minus 3 equals 8. If we move the 8 to the left hand side, this becomes 3p square minus 8p minus 3 equals 0. This is a typical quadratic equations, and that can easily be resolved. Okay, so here 3p squared times minus 3 give us minus 9p squared. The factor of minus 9p squared that can replace 8p is minus 9p plus p. Okay, so here become 3p squared minus 9p plus p minus 3 is equals to 0. So on factorizing, this become 3 open bracket 3p squared minus 9p close bracket plus open bracket p minus 3 close bracket equals 0. Now the common factor here between 3p squared minus 9p is 3p. So if we bring out 3p here, factor add become 3p into p minus 3 close bracket plus the common factor between p minus 3 is plus 1. So this becomes plus 1 is equal to plus 1 plus 1 open bracket p minus 3 close bracket equals 3. And here if we factor out here, this becomes 3p plus 1 into p minus 3 equals to 0. So that p is equal to 3 or p is equal to minus 3. But you recall that we said that let y is equal to s raised to power p from definition. We have to express y in terms of x. So that when p is equal to 3, y is equal to y is equal to s raised to power 3. Now, when p is equal to minus 1 over 3, y is equal to s raised to power minus 1 over 3. So this is the simple way to handle this problem. Seeing logarithm when the base are not the base are different, but the base of one is the log of the other one. So the best and the most appropriate techniques is to use the change of base. Please, if you like this video, please all you help me do, help me share and also subscribe to my YouTube channel. Help me grow it. Thank you very much. See you in my next virtual class.